Here we're going to look at topic 1, example 3, operations with rational numbers. Part A, the question is the sum of two rational numbers always a rational number? So for these two examples, part A and part B, it's going to be a lot of theory and just going over rational and irrational numbers, and there's not going to be a lot of math that we have to write out. Everything is already written here for us. So I just want to go through the theory behind it. So let's start with you can try several different cases of adding two rational numbers. And remember, a rational number is something that can be written as P over Q. Right, so we have some kind of fraction like 3/2 or 5/8 or anything like that. If you have something like radical 2 cannot be written as a number over another number, two integers. So we're going to say that radical 2 is irrational. So just remember that for a rational number to actually be, or for a number to be rational, you have to be able to write it as P over Q. So that's why these examples, 1/2, 1/3, 5/6, these are all rational numbers. So by trying several different cases of adding rational numbers, we can see that anytime that we add up two rational numbers, we get another one. So two rational numbers, we get a third, two rational numbers added up gets a rational number. However, there's an infinite amount of these examples, right? So we wouldn't possibly be able to test every single example by hand. So, and that's what it says here. In each case, sum is also rational. You can't try every pair of rational numbers. Since, again, there's an infinite amount of them. We can just keep trying and we would never run out of combinations. So how can we know whether it's true for all rational numbers? Well, what we can do is we can use variables in place of any of our numbers. All right, and what we're going to do is we're going to let A, B, C, and D be integers. And it's important that we state that they're integers because remember, rational number is going to have integers. And we're going to say that B and D cannot be equal to 0. And the reason for that is they are in the denominator. Okay. And it wasn't mentioned before, but this up here, P over Q, Q cannot be equal to 0 there. So what they're doing is they're taking this A, B plus C, D statement here, and they're adding them up, and they found a common denominator here. So your common denominator will be BD. They've kind of skipped that step. So your numerator will become AD, and the other numerator would be BC. So to find common denominators, you would figure that out, and then you could add these two up. When we added these two up, we then get this expression here, AD plus BC over BD. And what happens here, and this is kind of the key point here, is that since B does not equal 0 and D does not equal 0, BD also can't be 0, right? Because if two non-zero numbers multiply together, it would be impossible to get 0. Since we're multiplying integers, and this is kind of an assumption that they make, that they assume that you know, but since AD plus BC and BD are all integers, all of these numbers here are integers, then and BD cannot be 0, we already mentioned that, then the sum has to be rational. All right, so if we take rational, whatever numbers you plug in for A, B, C, and D, if they're integers and you add them up, you're always going to get more integers. And whatever AD, BC, and BD happen to be, they're going to be integers and they're going to be in the form P over Q, so that tells us that it is rational. So the question, is the sum of two rational numbers always a rational number? The answer would be yes. All right, adding up two rational numbers will always give you another rational number. Now let's look at part B. Is the product of two rational numbers always a rational number? We're going to do the same thing that we did in part A, using the same strategy, and use variables to represent any rational number. So instead of using numbers like 1, 2, 3, 4, 5, 6, we're going to once again use A, B, C, and D. Same rules apply here. A, B, C, and D are going to be integers. B and D cannot be equal to 0 because they're in their denominator, and then that would kind of negate the fact that it would be a rational number. So when we multiply these two integers here, actually let's highlight that instead. When we multiply AB times CD, we get AC over BD. And once again, because an integer times an integer is going to give us a new integer, then AC has to be an integer. And B times D, B and D are both integers, so when we multiply those, BD must also be an integer. Since B is not 0, D is not 0, then BD cannot be equal to 0, so that's important. And then since we already said it, since AC and BD are integers and BD does not equal 0, the product is rational. So what did we learn here? We learned that the sum of two rational numbers is always a rational number, and the product of two rational numbers is always a rational number. Now, why do we need to know this? Right now, you don't, but this will become useful as the year goes on and as you get further and further into algebra. There's certain cases and assumptions that you're going to need to make, or I shouldn't say assumptions, but there's going to be certain situations where you're going to need to know whether numbers are rational or irrational and kind of the rules that go along with that.